Welcome to Math 105, Chapter 8.4, where we talk about measures of dispersion. So we're going to be starting with just population variance and standard deviation. Now, depending on the type that we have, we're going to have a different equation. So it says if the values x sub 1, x sub 2, and x sub n, so if you have a bunch of x values, which are all the measurements of x, and in the entire population. So if all of your x values are of the entire population, then we can calculate your population variance. Whereas the sample variance is only for any sort of sample of the population with, again, some of these x values. So if we're asked to find the population, then we're going to be taking, and again, this is for variance specifically, we're going to be finding sigma squared. Now, this is the population variance. And we'll talk about what variance actually means. So notice that this one, its valued is squared. Okay, so it's going to look very similar to a standard deviation, but this value is going to be looking like it's squared. So then it's going to say we're going to take each of your x values and subtract it by the population mean, and then square those values. And then we're going to do it again for the next value. Again, subtract from your mean, squared, and we're going to sum all of these up. Now, what these in fact are kind of the errors in which these x values are missing your mean. So if they're very close, then the margin of error is very slim, which is great. However, if it's a lot bigger and further off from your mean, then that error is going to be significantly larger. And then, of course, we're going to divide by the total number that you have in your population. So again, I'll just describe what that was one more time. This is the error in which the average x value misses the mean. Now, this is a very long equation, which we can then simplify to something a little bit smaller. And because I wrote this a little bit larger than I intended, I'm just going to shift this over. So this has another equation to abbreviate it. It just says we're going to take the summation. So we're going to sum all of your x values starting at the first x value. We're going to subtract it by the mean, the population mean, and square those values, and then divide it by the total number n. So that's what you're going to be seeing on any sort of formula sheet or in your textbook. That's the one that's most common. So now that's for your population. Now with your population variance, to calculate your standard deviation, now it goes for always. Your population standard deviation is going to be square rooting your variance. This being your variance. Oops, I messed up right there. Variance. And that'll get you to your standard deviation. So always, and I want to make it very clear, to find standard deviation, we square root the variance. Always. So if that's for your population, then for your sample, it looks very similar. You're still going to have, now this time instead of sigma, we're going to have s squared of x. This is the sample variance. Now this is again calculated the same way. Instead of using the population mean, we're going to be using X bar, which is your sample mean. Again, we're still talking about taking the square differences. And in this case, instead of dividing just by n, we're going to subtract just 1 because it's not fully that population. And we can abbreviate this equation as the summation of X values, starting at the very first one, subtracting it by your sample mean, squaring those differences, and then dividing by 1 minus the total. And one more time with your sample standard deviation. We're going to take the square root of your variance. Sample standard deviation. And this is your sample variance. Again, always take the square root of your variance to get your standard deviation. Now, we've been throwing around the word variance a lot. So can you think of some synonyms that it might mean for what it might mean to be a variance, or just the word variance? Well, it can mean a number of different things. It can mean your discrepancy. It can mean some sort of fluctuation. Could mean it diverges from the mean, from the normal, or any sort of diversity. Now, I don't know if you have seen the show Loki, right? But they're talking about a variant, right? You have your original person, and then you have different variations or different variants from the mainstream version, right? So they are diverging, they are fluctuating from the original timeline, right? So think about that when you're talking about a variance. Now, we can have small or large variances if whichever word you like. If you don't like the word variance, right? If we have a small variance, it's not very diverse, right? It is very close to a small spread. So these are a lot closer together. So we'll just say that these are grouped closer together, which also means the spread isn't very big either. So variance, again, how much it diverges, how much it misses from the center value, like your mean. So we're nice and tight and close versus a large variance, a much more diverse, diverging from the middle, more discrepancy and fluctuation is found within these values. So in this case, we could say something like these are more scattered or spread. And if we were to compare these two graphs, well, which one would look like it has a smaller variance? It's grouped a little bit closer together because the average error that it's missing from your mean is a lot smaller, right? Well, this one would be a better fit to have a small variance because your mean, let's say your mean and your center is here, and we're not fluctuating too much from the center. Whereas the opposite is true over here. We have a lot more diverse values. So now it's being a lot more spread out from, again, perhaps your center somewhere around here. So the margin of error is just a little bit more, therefore it's going to be scattered further out. So the difference between your standard deviation and your variance, right? If we're talking about fluctuation or a divergence or a variant, well, you have your original, you have your mean, and we're talking about the average error that each point is from the mean. So your variance is the average degree each point is different from the mean. Highlight or emphasis on the average degree, whereas standard deviation is the measure of the actual spread of values. So this one, highlight or emphasis on the actual spread. So standard deviation is your spread, whereas your variance is just the average degree by which each of the average degree which each of these values is off by. So that being said, if we were to do the following, right? The following is a sample of incomes in thousands of dollars of 8 U.S. residents selected at random. And let's compute the sample mean and standard deviation rounded to 1 decimal place. What is the percent of scores that fall within 1 standard deviation of the mean and then 2 standard deviations? So if we were going to do this, I'm sure we can all find your mean by hand by adding all of these x values up and then dividing. But let's make your calculator do a little bit of that work. So notice that these are all just one singular type of value. Unlike last time in 8.3, we had 2 values. We had your x value and its probability. So we're going to calculate your mean just slightly different from your calculator than the last time. So in your calculator, oh, let's try that again. We're going to be hitting the following buttons. So stat, edit. We're going to place these values in list 1. Because there's no other values to worry about, we do not need to put anything in list 2. So then we're going to be hitting second mode. And then we're going to hit stat, calc, 1 variable or 1 bar statistic, 1 bar stat. And then we're going to take a look at what pops up. So let's go over to our calculator. Now I already put mine in, so I'm going to start fresh. We hit stat, edit, and making sure all of your x values have gone in, and double check that all of these are correct and accurate. Now, once they're all in list 1, we're going to hit second mode to go back to a nice clean screen, then hit stat, and then you're going to move your cursor over to where it says calc, and then we're going to select that first one, 1 bar stat. Now, if yours is an older calculator, you can just go right ahead and hit enter. Ours, it just wants us to verify that list 1 is the list that we want to do this to. So we're just going to hit enter, and notice that all of these values end up popping up. Now, of this value, we don't need a whole lot. We're only going to be taking the very top value that says X bar, that being your sample mean of 40. And then I should have said this before, are we working with a sample or a population? So what did it say in example 1? Well, it said we wanted a sample, or we had a sample of incomes. So that means anything with that sigma X is not what we're going to be using. And because we are given a standard deviation, right, we don't need any of the following two after the 40. So now it's between these next two values, Sx and sigma X. Sigma, the lower of the two, the one that says 24.5, that is going to be your population. And the one above it, where it says Sx 26.19, that is going to be your sample. So we're going to be taking that value. So in your calculators, we now have your sample mean. X bar is equal to 40. We also were told your sample standard deviation, which we said is SX. Rounding to 2 decimal places, it's 26.19. I do want to make a note here. If population standard deviation, we need, or you're going to use the one that said sigma X. That was if it said population. Ours told us that we're working with a sample, so that's why we're going to be taking the ones that say sample. Okay. So now when it says calculate to round to 1 decimal place, oh, well, we could have rounded ours to 1 decimal. I'm just going to keep it for right now. So then let's figure out, not so much the percent yet, but let's figure out, well, what range of these scores, of these incomes fall within a certain number of standard deviations. So if we were to make a picture, this one being here, if I were to draw a picture, your mean is right in the middle at 40. And your standard deviation is the amount of spread. So when it says what scores, or it shouldn't say scores, it should say income, right? What incomes fall within 1 standard deviation? Well, 1 standard deviation is the amount of spread. So we want to figure out on either side of your mean, what is the 1 standard deviation? How far, what would be the next range of your incomes? So to either side, we want to know, well, what would these X values mean? So if we're talking about 1 standard deviation, we're going to take your sample mean. And if we're talking about going less than or below your mean, we're going to subtract. Whereas if we want to get above your sample mean or your population mean, we're going to add. Now we're going to add the amount of standard deviations it wants us to find. So ours being 1 standard deviation, well, we just need to add 26 or subtract 26.19. That is just 1 standard deviation. So this X value here, this new X value, or the new range, is going to go between 13.81, because that is your 40 here. Actually, let me redo that part 1 second. Let's see. I'm going to rewrite it down here. Should have been minus your SX. So that's minus your 40. There you go. That way, you're not perhaps as lost as to what we just did, what we were adding, subtracting by, plus the 40 on the other side. And then we get, what does that say? 66.19. There you go. So within one standard deviation, so the amount of spread, so going from one side of your mean to the next sort of percentage of income spread will fall between those who make 13,000 and those who make 66,000. Now we don't know the percentage yet. That's what we're going to be doing next. But let's do it again one more time, but with two standard deviations. So I'm going to draw our picture one last time. Draw that a little bit better. Okay, so you have your mean in the center. Now this time we want two standard deviations away. So something a little bit further than the last one. So again, we're taking your mean. We're going to subtract if it's the less than half, or add if it's the greater than half. And if we are looking for now this time, two standard deviations away, then instead of just subtracting by one or adding by one, this time, if it says 2, we are going to take 2 and 2 and multiply it to your standard deviation. So in our case, we have 40 minus 2 times 26.19. Doing it again for the latter half. Let's see, 2 times 26.19. So we should get negative 12.38 and 92.38. Now, is it actually possible to make a negative income? No, most likely not. But again, this is just a spread, so we can keep taking standard deviations because we can certainly make upwards of $92,000. So it can go up on either end. Now, again, we do not know the percentage yet of who will make between these values, but that is what we're going to be doing next. Now, if it said 3 standard deviations away, we can do it one more time just by going out and changing that to a 3. Now, let's take a look at these next rules. So let's figure out, well, how do we get these percentages? Well, and I'm actually going to change this part. Oh, I'm gonna reorient this a little bit better. If you are ever thinking about getting an iPad to use your notes, I highly recommend it. Like, look how easy that was. I didn't like how this, where I placed it originally, and now I'm just moving it and it looks great. All right, so to get these percentages, right, we have 2 rules that we have to figure out. One being the empirical rule and the other being a Chebyshev inequality rule. Now, there are a couple differences with these. I will make a big thing. In our class, we're going to only be using empirical. It's what we're going to be seeing most often. Chebyshev, you don't use as much. Okay, but just notice the differences in appearance between the two, right? What can you determine? Well, for the empirical, we have to have this normal bell-shaped curve. So for empirical, must have normal / symmetrical bell shape curve. So this one has to be nice and bell shaped, nice and symmetrical, whereas this one doesn't have to. This can be any shape of curve. So any shape of a curve. Now, for these as well, right, we have here 3 standard deviations, 2 and 1, again on the other half, whereas here we have 2, 3, and this one actually looks like it stops, right? In ours, it can actually keep going. We can keep going and taking -4 standard deviations. Oops, too far. This one again, -4 standard deviation, or sorry, +4 standard deviations, and we can keep going on either end. So in this one, we can keep taking standard deviations away. Whereas this bell curve, we stop after 3 standard deviations. Now, because in this one, they have given us a range of these percentages, look at 99.7 is just almost there, right? To be completely under the curve being 100%. Whereas here, it's going to give us a margin, a minimum of at least 88.89% who fall in between 3 standard deviations. And if we did 4 standard deviations away, that would be 93.75% of it at least. And I'll put that here, 93.75%. And we could keep going, right? We want to achieve 100, right? So this one is a minimum value. So that being said, I had to make an assumption that this was normal and symmetrical in order to fit the empirical rule. Again, the ones that we're going to be experiencing is empirical. So that begs the question, right? If we have 1 standard deviation here, what is the percent that falls under the first standard deviation? Well, 1 standard deviation away, right here, I'm going to redo that. 1 standard deviation away here is how much percent? Well, this is 68%, right? 68 fall within this range. So that means up here, we got 68%. Actually, I don't like how I wrote that. 68%. What about 2 standard deviations away? Well, 2 standard deviations is now just a little bit bigger over here. Continuing up, 2 standard deviations away will be 95%. This is 95%. So with that being said, can you pause the video and try out example 2 on your own? We're going to be rounding to 1 decimal place this time. All right, so we're going to go back here. We're going to hit Stat, Edit, clear out this list. Now in our example 2, we are talking about a sample of unemployment rates in percentage points in the US from 1990 to 2004. So they're giving us these percentages. Oops. So 4.7, 5.9, and 4.9. So we have all of our given data. Double check that it looks good. It does. We're going to hit second mode, then stat, calc, 1 variable statistic. All of my values are in the first list. That's great. Now I'm going to look up here, right? The things that I need, if I know it's a sample, I'm going to be using your sample standard deviation. So that being your X bar is 5 and your sample standard deviation is the one that says 0.6 SX. So let's go ahead and record that. This is your sample standard deviation. Okay, so we have that information. We rounded correctly. And now it says, assuming the distribution of unemployment rate is in the population is symmetric and bell-shaped. So they're telling us the type of curve we have. 95% of the time, the unemployment rate is between what values? So they're going to tell us that it's symmetrical like this. So something like this. You have your center value here. And you have your standard deviation. Now, if we're talking about 95% of the data, 95% of the data, how many standard deviations away from the mean is that? I hate how I did that. One more time. There you go. All right, so 95%, they're telling us 95% is 2 standard deviations away. So we're going to take 2 standard deviations away from your mean, whether we add or subtract. So our values, we have the lower limit to be 5 minus 2 times your sample standard deviation was 0.6. And again, the upper limit, doing the same, but now adding. We get 3.8 and 6.2. So what does that mean in the context of a sentence? Well, we now know that the approximately 95% of the time, the unemployment rate is between 3.8 and 6.2%. So that's what they're talking about. So that's if we have one variable. But let's say we have a finite random variable. So now we're working in 2 variables. So it says if x is a finite random variable, again, with these x values, then how do we calculate your variance? Well, your variance, again, being your sigma squared or sx squared, we're going to be taking the summation of your x value minus your mean, so still with the errors, squared, right? However, because there's now 2 variables, probability, we're going to be doing that same thing we did last time, except now we're going to be multiplying by the probability of that x value, x sub 1, or in this case, x sub 2, or we keep going, x sub n until you run out. So your abbreviated formula says we want the summation of x values starting at the first one minus the mean, whether that's population or a sample. We're going to take the square differences. Now we're going to multiply by the probability of those x values. It's x sub I, given however many we have. Now, again, I want to be making sure that if you guys use these notes later on, you're like, what does that even mean? It just says take the square differences of the mean and multiply to the probability, then sum up the values. Again, this is for your variance. To find your standard deviation, give a guess as to how we're going to be finding your standard deviation. Well, your standard deviation is always the square root of your variance. Because it's so important, I'm going to write one more time. The standard deviation, or to find standard deviation, square root, variance. So important. So what we're going to do next is actually calculate it by hand first using this chart, and then we are going to have you do it on your calculator. Then you guys get to choose which version you like best. All right, so we have your X values, we have your probability, and now what does this first one mean right here? Well, it says X times P of X, right? So we're going to multiply, as it's telling us to do, multiply your X value here by its probability. So we're going to multiply down to get 2, to get 4, and maybe I put a few to the side. 20 times 0.2, 30 times 0.3, which is 9, and then again 4, 5, and 6. All we're doing is just multiplying these values and placing them below. So first thing, we said multiply X by the probability. So that's all we did. Now in your next part, right, it says X right here minus, well, what is that symbol? Well, that means your mean, right? So this next part says, hey, we're going to be subtracting your X value by the mean. But do we have your mean? No, but we have seen this part before, right? So back in 8.3, to calculate your mean, we said we actually have to add all of these values up for your expected values. So we can total them all up and we get 30 as your expected value here, which is your mean. So we're going to be subtracting 30 from your X value. So 10 minus 30, negative 20. That's okay. That negative is not going to stay for very long. 20 minus 20, 0. Come on. 20, not 20. 20 minus 30. Sorry, I looked up and I saw the 20. I wrote it, so we got negative 10. This one, oops. This one, I'll write it one more. We got 30 minus your 30 here for 0. And we're going to keep going. So 40, 50, and 60. Okay, so we have that next part completed. Now let's look at what's going to happen below. Well, it says X minus your mean. That's what we just did from before. And now we're going to square those values. Square above values. So we have negative 20 squared, which makes 400, or negative 10 squared to make 100 and see if you can complete the rest of the table. 0 squared, 100, 400, and 900. Okay, let's see what we can do one more time for this last one, right? We're almost done. What says x minus your mean all squared. Okay, so we just did that part. So the one above it times, well, what's this mean? Well, that means your probability. So we are going to multiply the above by the probability. So that means your 400 times your probability, which is 0.2. 400 times 0.2 is 80. Let's do it again. 100 times 0.2, which is 20. One more time. We have 0 times 0.3 to be 0. So see if you can do the remaining. Okay, so now that we have run out of your table, let's look at your chart, right? So we calculated your mean, we squared it, then we multiplied by your probability, and then what is left to do in this equation? Well, now we have to start adding. So we're going to add all of these values up. And we get 240. Now what's produced is this sigma squared, your variance. So this one is your variance. And how do you find your standard deviation? Well, we're gonna square root your variance. (15.49-ish). So if you are someone that likes to do it by hand, definitely feel free to do so. Otherwise, we're gonna learn how to do it on your calculator. So I would say pause the video first, write all of this down right where you see it. If you're using your guided notes, I wouldn't leave anything up to finish. Like I would literally write every single thing down that you have here. So let's try it with your data one more time. So we have your X values, which is in list 1, and your P of X values, which is in list 2. So let's put that into your calculator. So stat edit. Notice that I'm not using Desmos anymore. I'm sure Desmos has the same capability. I have not explored it as much as maybe I should. So I'm just going to clear out all of my lists. My X values are going to go into my lists. It's 10, 20. Sorry, there was a knock at my door and it scared me for a second. So I might have to go and check back in. We'll see if I need to do that. All right, so we've entered it in. I'm going to hit second mode. And then first thing we have to do is the exact same that we did back in chapter 8.3. So we're going to hit second stat, math, sum. So we want to go ahead and calculate your mean. We're going to hit second 1 times second 2, oops, and close your parentheses. Now this will give us your expected value of 30, your mean, right? We've seen that 30 come up. Great. Now we're going to go and hit, we're going to go find your variance. So we're going to hit second stat, math, and one more time down to sum. And now it has a parentheses, and let's open up another parentheses. Then we're going to hit second 1, so your x values, minus your 30, your mean, close your parentheses, and then we're going to square. Your square is right next to, or right on top of your log symbol on the very left-hand side, kind of by the 7 or the comma if you're seeing it. So we square it, we square those differences, and now we're going to multiply by the values in list 2. So times second 2 in list 2, close your parentheses, and then go ahead and hit enter. So there's your 240, that's your variance. Now we left a space, part C, it said, well, how do you calculate your standard deviation? How did we do it by hand? Well, by hand, we said we are going to take your square root of your variance. So let's go ahead and hit your square root button, which we're going to hit second, second squared. So the second blue button, and then your x squared button. Again, the same one that you may have used from previously. We're going to type in 240, go ahead and hit enter, and there you go. You have 1549. Oops, yep, right here. So how do you get your standard deviation? We said we're going to square root the variance. So we're going to hit second x squared, and then put in your number. And there you go. Now the last thing we're going to do, because we have multiple variables that we've been working with, so we've just seen what we have to do when it's one variable. So if they give us just one set, now if they've given us 2 sets in the last one, well, what do we do if it's a binomial random variable? So things that only have 2 outcomes. So either it's a success or deemed a failure. Well, because there's only 2 outcomes, how to calculate your variance and standard deviation is very, very easy. So what we're going to do to calculate your variance when it's a binomial random variable, we're going to take your number of trials times the probability of success times the probability of failure. So that's your variance right there. And if we want to look for your standard deviation, well, how do we always calculate your standard deviation? We take the square root of your variance, your n, your p, your q, this all being your variance. So let's try example 3. Now, I do think you can do it on your own without me, so definitely try to pause the video. If you don't know what the expected value is, please go back to chapter 8.3, the section we had just before this. So it says, according to a study, the probability that a randomly selected teenager played a computer game at least once during the week was 0.48. Let X be the number of teenagers in a randomly selected group of 30 who will play a computer game during the next 7 days. So what did they give us? Well, they told us your probability of selecting someone who's at least played once during the week is 0.48. They have also told us the number who are in our group, which is 30 teenagers have been selected. Now they didn't tell us your Q. Actually, before I do your Q, we don't really need your Q for this first part, right? When it says compute your expected value, well, your expected value is by multiplying your N, the number of people, times your P. 30 times 0.48, which is 14.4. So on average, 14.4 teens will play a video game at least once a week. So these are the the teens that'll play at least once a week, right? So what about your standard deviation? Well, we're going to need your Q for that, your probability that it's not somebody who has played once a week. So they haven't played at all. So how do we get Q? Well, Q is the opposite of P, the opposite being 1 minus P, which means 1 minus 0.48. So Q is 0.52. So your standard deviation is the square root of your variance, or just the square root of NPQ. NPQ. Let's see, the square root of 30 times 0.48 times 0.52. So about 2.74. So the average spread, so the average amount of people or from person to person will be about 2.74 people. If we're talking about the variance, it's going to be the average amount of person or average spread from your mean of 14.4 would be that amount.